Hello friends, today in this particular video I am going to talk about development of different microstructures in an iron carbon phase diagram. So to start off with, let's start with the Pearlite microstructure. So with the Pearlite microstructure will be formed when you cool an alloy, an iron carbon alloy of composition 0.76 when you cool an iron carbon alloy which contains 0.76 weight percentage of carbon from a temperature above 727 degrees centigrade. So 727 degree centigrade corresponds to this particular line. Let's say I'm cooling my alloy from this particular temperature. So I'm bringing the temperature down slowly because all these reactions which you are talking about are very slow reactions, so that the resulting states or phases are equilibrium states and equilibrium phases. Then at this particular point, at the Untitled point, the reaction will happen where gamma austenite, the solid phase, will decompose into two product phases, the alpha ferrite phase and the cementite phase. The reaction and all those things we have discussed later. Now let's say I'm bringing it to room temperature, then the resulting microstructure will be looking like this. It contains alternate layers of alpha and cementite. So the natural question arises, which one among this is alpha ferrite and which one among this is cementite? So in this particular structure, these thick and light layers corresponds to alpha ferrite and this thin and dark layers corresponds to cementite. Now talking about the mechanical properties, this particular but before that, this particular microstructure is called Pearlite microstructure. It is called Pearlite because in appearance it looks like the mother of pearl. So now talking about the mechanical properties of alpha ferrite and cementite. Alpha ferrite, we have already discussed that it is very soft and ductile, and cementite is very hard and brittle. So the mechanical properties of an alloy with a pearlitic microstructure will be in between these two. Next, let's discuss how pearlite phase is formed. Now talking about the formation of pearlite phase, it's very interesting. See, this is one of the fundamental concepts that you should keep in your mind because this will enable you to understand further concepts very clearly. The concepts I will describe in the next videos very clearly. So here we go. In that particular reaction, we told that the parent phase has a 0.76 weight percentage of carbon, and now talking about the product phases, in alpha ferrite we have a carbon percentage of 0.02 weight percentage. Then in cementite we have somewhere around 6.7 weight percentage carbon. So that what that effectively means, this whole particular reaction will happen after diffusion, so as shown here. So this is the mechanism of pearlite microstructure formation I'm showing here. So here you have the gamma austenite, the parent phase. Now what happens, these are the product phases, this is the cementite phase and this is the alpha ferrite phase. How it forms, as you can see, these red arrows here, they are denoting the movement of carbon. As you can see, it is moving towards the carbon rich area as it forms. It is moving towards this thin dark layers of cementite. So this is the process, this is how the diffusion of carbon happens, and this is how the pearlitic microstructure forms. The layered pearlite, the one reason for pearlite to assume a layered structure is that the carbon atoms diffuse only to minimal distances. So that's yet another reason. In perlite itself, we have two variants. We have coarse perlite and fine perlite, which will be discussed when we start talking about isothermal temperature transformation diagrams.